Oh man, this was a tough lab. I sure hope my lab partner's okay.
Hi, I'm Dominique Galvez,
And I'm Mason,
and this is Lab9, Diffraction.
under Raphael.
We used this setup here for the qualitative diffraction experiment, and we used this aperture size to calculate the Z effective of the system by assuming our Fraunhofer number would be less than 0.1. When we use the 160 micron width slit, this is our Fraunhofer regime. And when we move the detector closer to the aperture, we see it goes into the Fresnel region.
When we replace the 160 micron slit with the 40 micron slit, we can see that the peak size increases. This makes sense because as we decrease the slit size, the peaks should increase.
This is the Fraunhofer pattern for the 40 micron double slit separated by 250 microns. And this is the 40 micron double slit separated by 500 microns. As you can see, there are more peaks and they're much closer together. As we increase the slit size from 40 to 80 microns, the width decreases. This is the triangular aperture in the Fraunhofer region. This is in the Fresnel zone. This is the Fraunhofer region for the square aperture. When we move it, this is the Fresnel zone. This is the Fraunhofer region image for the circular aperture. As we move it away, we see the Fresnel patterns emerge.
Experiment 2 is qualitatively testing the Fraunhofer diffraction pattern of the 800 by 400 slit here. To do this, we took an image of the Fraunhofer diffraction and imported it into MATLAB. From there, we fit the sync function to this, and this is the graph we have here. We then tested how accurate this graph was by calculating the I of the first peak over the I maximum, which we got to be 0.048 with a 6.55% error. We then tested this again for the second highest peak with a I over I naught of 0.025 with a 56% error. Another interesting thing to note about this experiment is that the peak does not lie in between the two minimum. It is shifted slightly to the right.
For the third experiment, we did the same as the second experiment, but with a circular aperture. So we have this in the Fraunhofer region as our image, and we plotted it in MATLAB and got this SOMFIT function. Then we compared it to the SOM function and got 9.98% error and a 4% error at the first and second maxima. As with the sync function, the SOM function is also not symmetrical.
The error in our last two experiments is likely due to some misalignment or us not being exactly at the Fraunhofer regime.